Thank you. Thank you all for coming tonight. We're delighted you can make it. Welcome Gauchos as well, coming back. I'm Joel Rothman, the Director of the Center for Aging and Longevity Studies, as Julie said. I am also the very proud recipient of the Wilcox Family Chair, and I'm happy to say Sue Wilcox is in our presence, and I'm deeply grateful to her for providing that chair, which is really in the end, still louder, which is, I have to get it about a quarter of an inch away from me, really in the end what precipitated my plans for building this center. So she's been at the very beginning of this. Of the center, and I'll tell you a few words about it. So I also want to emphasize what Julie already said, that our last lecture is still to come. So I would encourage you to come to Nina Miolane's talk, which is on a quite different subject. It's the impact of AI, artificial intelligence, on aging and longevity and health in general. I think it'll be a really interesting lecture. Let's see, oh, yes. And I need to express some other thanks right now. Certainly, Alumni Affairs, Julie, has done a wonderful job of organizing this. In fact, she initiated with Nicole a discussion to create this series, which we're very grateful for. Samantha Putnam has also participated in getting this together. Nicole has done a fantastic job for the center in general. Nicole is a professor in psychological and brain sciences, and some of you may have heard her talk a couple lectures ago. We would not be here without Nicole's wonderful guidance and help throughout all processes, from the design of the website to the grants that got some of our early lectures going, and to this event and many other events. She's the Director of Education and Outreach, and we're really grateful to her. And we're also very grateful to Diana, who you just heard from, Diana Thomas, who has given of her time to support the center and take care of a lot of the administrative duties, and has done so much to help support the center as well. And I also need to thank the Direct Relief here for providing this wonderful venue. We are so grateful to them for doing that, in particular Martha Vasquez, who has helped with that, and the Santa Barbara Independent, who has helped us publicize this series of lectures. So the Center for Aging and Longevity Studies, or CALS, is a major science and technology research center that's devoted to improving human lives by extending the period of health span, the healthy period of life, and forestalling age-related diseases, and also guiding the impact of this technology and science on society. And we encompass a range of research domains, as shown in this slide. And I know that those of you who have been here in past lectures have seen this and heard this, but we now span 43 faculty, 43 research groups across 17 academic departments. So we are one of the most interdisciplinary such centers anywhere, one of the most interdisciplinary centers at UCSB. We have about now close to 400 affiliated researchers who are involved in all aspects of aging and longevity. This lecture series represents only 6 of those faculty out of 43 faculty. So you're just getting a little snippet of all the things going on in CALS. CALS spans biomedicine, engineering, computer science, physics, psychology, chemistry, economics, actuarial science, and social sciences, and the humanities. So we are quite broad spanning, and therefore I think very rich environment for considering all aspects of aging and longevity. We're advanced by some state-of-the-art facilities. If some of you are interested in seeing them, we welcome you to come by for a tour. We have some very advanced instrumentation that is speeding up discovery in this area remarkably. And we also are developing a clearinghouse of reliable information that is available to the public at no cost, that will guide you in making decisions about interventions you might consider that might have an effect, a positive effect, on extending your own health and health span. All right, I think with that, I think I've covered everything I want to do. I'm going to turn it over to the Director of Education and Outreach in CALS, Dr. Nicole Albada, who will introduce our speaker, Karen.
Hey, hi, everybody. It's good to see you. It's nice to see familiar faces in the audience that I've seen at a few of the other talk series, so welcome back this evening. It's a true pleasure to welcome you today to introduce someone I'm honored to call both a colleague and a friend, Dr. Karen Szumlinski. Karen and I have been colleagues since 2018 when I joined the faculty. From the very beginning, she stood out, not just for her sharp scientific mind, which you'll hear more about this evening, but also for her boundless energy and her generosity with students and peers. She brings a remarkable passion to her work, and if you've ever had a conversation with her, you know she's as animated talking about molecular pathways as she is about her weekend adventures. Karen is not only a professor in my department, the Department of Psychological and Brain Sciences, but she's also affiliated with Joel's department, Molecular, Cellular, and Developmental Biology, and affiliated with the Neuroscience Research Institute, as well as our own Center for Aging and Longevity Studies. She's very busy. Karen's research focuses on the biochemical mechanisms underlying changes in brain and behavior produced by chronic exposure to drugs of abuse, particularly psychomotor stimulants and alcohol. Her work has significantly contributed to our understanding of neurological pathways and processes in the brain that relate to addiction and neuropsychiatric disorders such as psychosis and depression. The work that's most relevant to the lecture this evening uses mouse models investigating how glutamate signaling, which she'll tell you all about, contributes to cognitive decline during aging, especially in individuals with heavy alcohol consumption. Karen is a fellow of the American College of Neuropsychopharmacology and a member of the Research Society on Alcoholism and the International Behavioral Neuroscience Society. Her research has been recognized internationally with continuing NIH grants and is highly impactful with over 5,000 citations. Beyond her research, Karen is deeply committed to community outreach and education, so we share that passion. She co-founded the Brainiacs program. I don't know if anybody's ever heard of this program, but it's a program that brings neuroscience education to the local schools through interactive presentations and activities with actual brains. She brings brains into the schools. In fact, she's nicknamed the Brain Lady among her students. Today, Dr. Szumlinski will share her insights on the brain, alcohol, and accelerated aging. So maybe with a drink in hand, or maybe not, please join me in welcoming Dr. Karen Szumlinski.
Thanks so much, Nicole. Actually, my gang is at Alumni Elementary today for Brainiacs. This is really bad. Yeah, my gang's actually at Isla Vista Elementary for our last of our, we did 12 Brainiac events this year. So I'm sad to miss the last one, but I'm very, very happy to be here with you guys, and I wouldn't trade it for the world. So thank you so much, Nicole, for inviting me to come. It's truly a pleasure to tell you about some of the work that I've been doing. I know a lot of folks are scared about what I'm going to say, but I think if you're between the ages of 50 and 65, you got something to worry about. But if you're over the age of 70, I think I have some data you're going to be very, very happy to see. So, all right, now I got to figure out how to make this work. Oh, shoot. Wait, how's it go? No. Hold on, it will go back. Hey, I got the microphone to stay on my ear, though. That was pretty good. I used to play in a band, but I didn't sing. So,
Right now?
let's see. There we go. So from the moment I joined UCSB back in 2005, so it's my 20th anniversary of being at the university, I became very, very interested in the neurobiology of binge drinking. And one of the reasons why is because this form of alcohol consumption is the most prevalent form of alcohol abuse worldwide. And if you're not familiar with the term binge drinking, what it refers to is a specified amount of alcohol within a 2-hour period that will bring your blood alcohol level to 0.08 or higher. In other words, you should not be driving. And that equates to about 4 to 5 drinks in a 2-hour period for women, 5 to 6 drinks in a 2-hour period for men, depending on your body size. Now, when I say drinks, I'm referring to this is really weird because you can't see the laser pointer. My goodness. So I'm referring to standard drinks. However, we live in Santa Barbara, and very rarely do we ever consume a standard drink, right? So even a beer that you would get at any place around town is not going to be a 12-ounce beer. It's going to be 16 ounces or 22 ounces. And we know we can get all sorts of pours on our wine. So the key point is when we're eating out or drinking out, or maybe not paying attention when we're at home, we are very likely consuming more than a standard drink. Now, on top of being the most prevalent form of alcohol abuse, it is also the most costly. And this is relevant in terms of us being taxpayers. About $200 billion a year we lose in the US due to costs associated with loss of productivity, car accidents, healthcare services, and crimes. And sad to say that of all of the US, California actually leads the way in terms of the highest cost associated with binge drinking. So I've been very much interested because it's very prevalent, it's very costly. But when we think about binge drinking, what do we think of? We think of what's going on down the street, right? We think about these parties and keg stands and beer pong and all this sort of stuff. It's something that you do late in high school, even though it's illegal. And I am Canadian, so I was allowed to do it in high school. But, this is the behavior that young people do, right? It's not what we do. However, even though most of us think we're too old to play beer pong, there's still some of us out there that are capable of having a good time. And I'd like to point out that this lady right here, her sash says 100th birthday, and there she is playing beer pong with the rest of them and the best of them. This is my favorite though, the grandma doing the handstand at the kickstand. So while I can't even envision doing a handstand anymore, even against a wall with someone helping me, there's no way I could ever do a keg stand. Now, while we think, we're too old for this, we don't play these goofy drinking games anymore, I would let you know that 50% of the binge drinks consumed in the US is by college kids, and the other 50% is the rest of us over the age of 35. So even if we're not doing a keg stand, or we're not playing beer pong or flip cup or goofy games like that, we are still engaging in this high level of alcohol intake. And like I said, we are all engaging in this high level of alcohol intake. So here is me with my darling husband, who is also faculty in psychology with me. So I'm guilty of doing it too. And when you think about society, society is set up, particularly living here, to engage in binge drinking. Even the Rotary Club has a happy hour happening at Rare Society. I don't know if anyone here is in the Rotary Club, but I'll let you know, they got some happy hours at Rare Society. Moxie, this one shocked me actually to find out that Moxie, a children's science museum, also has a happy hour. But the best happy hour it seems in town, in case you're curious, looks like Cruisery because it's like 4 hours long. But the point being is, these are 2-hour to 4-hour windows where drinks are cheaper, get some appetizers for a cheaper price, but it's almost promoting drinking a lot of alcohol, again, in larger pint glasses than a standard drink in a short period of time. Moreover, we know, particularly for folks who are new parents, that drinking happens a lot at home. And in fact, the UK, when I was in the UK, my kids were, I think they were 2 and 3 years old. They had an advertisement campaign called the Bin of Shame. And sadly, mine is twice the size of that, and it looks about the same. But it was geared for young parents who aren't going out and doing keg stands. They're not even going to bars anymore. They have little kids at home. So what do? You sit around with your bottle of wine and your case of beer, and your kid falls asleep on your shoulder, and you pick them up and you put them to bed, and then you're free for the rest of the night. And this is truly, genuinely, I know my friends in Canada who have kids drink like this. Every parent I know in Santa Barbara who partakes of alcohol does this. And you don't realize as you're watching television, just like you don't realize you've eaten an entire bag of potato chips all by yourself, you're ghost eating, you're ghost drinking. You're like, oh, I'm going to go up, get another beer, go sit down, watching a game or something like that. So in a 2-hour period, you end up consuming an excessive amount of alcohol. And then once a week, you get the reminder of just how much when you go to throw your recycling bin out. So yeah, so they actually launched an ad campaign in the UK to try to just make people aware that, hey, yeah, you're safer off at home drinking. You're not going to be driving, not likely to hurt yourself. Although, you know, if you try to cut limes after too many margaritas, you just might hurt yourself. But let's hope you're careful. But no, it's a serious problem. And just the thought of you being home and safe doesn't give you, you know, I guess I don't know what the word is, permission, but you should be monitoring how much alcohol you're consuming. And we know that this drinking at home issue became a really big problem that was exacerbated by COVID-19. And while there's lots of different reasons why people might have increased their drinking, most of the time it was related to lockdown. And that's what's illustrated here. These are the scores from an experiment related to having an alcohol use disorder. So as we moved into lockdown, individuals like us in California who were under lockdown had a progressively increased diagnosis of alcohol use disorder. And I know in my case, it was most certainly related to having to do with the children at home and the Wi-Fi never worked. We stopped teaching for a bit, but only for a short bit. And then we had to recreate everything and figure out how we're going to do it all from home. Then there was the quarantini parties that I would have with my friends that I couldn't see at conferences anymore because all the conferences were canceled. And then there was just sometimes where folks were just simply feeling lonely and really had nothing else to do but drink. And it was for this giant spike in binge drinking activity that happened over COVID-19 that I've become very, very interested in the effects of social isolation on drinking behavior across the age span. But that will be 2 years' time when I get invited back to give that talk, because we're still running those experiments. So a recent study out of University of Michigan actually produced some very interesting results. So what they did, this is post-COVID now, we know there was a big surge in alcohol drinking. Actually, alcohol drinking in women went up by 300%, where it only went up by 85% in men. So women are definitely affected more in terms of their increase in alcohol drinking. And they're saying, hey, what happened afterwards? Here we are a couple of years out. What's the status of drinking in older aged individuals? So they're looking at folks between 50 and 80. I fall into that category. And perhaps not surprising, 70% or so drank alcohol in the past year. But what I highlight here is that 20% of those individuals are saying that they're drinking more than 4 times a week. So that is a bit above moderate normal drinking. And then related to dealing with binge drinking, about 30% are reporting having 6 or more drinks on occasion. I've only had 2.5. I've only had 2.5 so far, so I'm still good. But so people are binge drinking. And the big question is, what are the risks of binge drinking in older age? And I don't mean like older age, 90 years old. I'm talking between 30 and 70 years old. We know there's a whole ton of literature out there on drinking during junior high, drinking during high school, drinking during college. But there's not a lot of research that is specifically trying to focus on how your age in later life, after the age of 35, really impacts your body's response to alcohol. But we do know a few things. Sadly, our ability to metabolize alcohol slows down. I guess you can look at it from a financial perspective. What that means is you will have higher blood alcohol levels. You will feel more drunk on less alcohol. So financially, that would be great. However, most of us continue our patterns of drinking. So what that means is if we're going to have 2 glasses of wine with dinner, the 2 glasses of wine is going to feel like 3 glasses of wine, 4 glasses of wine as we get older. And that, of course, impacts drinking and driving and all those sorts of things. We also know, it's the reason why I'm wearing these shoes and not my giant stiletto heels that I used to wear before, our balance and muscle strength and all of that sadly starts to wane, even if you're trying to be really, really healthy in our coordination. So getting intoxicated when you're older is going to increase your risks of falls and injuries, etc. And then, of course, now we're on medications that we might not have been on when we were younger, and that those medications can have interactions with alcohol that could impact us. But above and beyond all of that, we know that alcohol drinking can cause cognitive impairment, can cause difficulties in thinking and remembering. And this is a really busy slide. It is not mine. Basically, what it's showing is they're looking at different ages. So folks in midlife, so presumably 35 to 40. Then we've got 50-year-olds, 60-year-olds, 70-year-olds. The nice news, pattern is the same. It does not get worse. But the pattern is higher risk of cognitive problems associated with the amount of alcohol that you drink each week. So if you drink more booze, you're going to have higher risk of cognitive impairment. And we know, at least in terms of number of drinks per week, in case you're curious, is that moderate drinkers, so that's 7 drinks to 14 drinks per week, not per day, per week. I've already had 2.5. I had 3 yesterday at the Draftsman. My birthday was on Monday. I'm not going to tell you how much I had then. I'm definitely in this week anyway. I'm in this moderate drinking. Are 60% more likely to experience cognitive decline. And this is referred to as alcohol-related dementia. And when you look into the brains of individuals with alcohol-related dementia, what you see is a brain that looks very similar to a brain of an individual who has passed away with Alzheimer's disease. So here's our normal brain. My students are showing some cow and pig brains to the kids right now at Isla Vista. You have nice big bumps and you have little gyri and sulky and everything's all packed in and it's nice and thick. And what you see in terms of the cortex is now you're starting to get holes. The tissue is dying, it's receding, and now you got these big holes essentially in your cortex. And the effects of alcohol are very, very similar. So there's been a lot of work on this. We know alcohol is a neurotoxin, and this work essentially has focused a lot on how alcohol can activate your immune system. I don't know if anyone's ever, had a couple of drinks, suddenly their sinuses kind of start acting up. This is something I've noticed since I've gotten older, weird like sinusy allergies, but it will activate your immune system. It also activates a whole bunch of oxidizing mechanisms that can cause cell death. And these all put into combination, and different people study different aspects, can affect all sorts of organs. We're very familiar with cirrhosis of the liver, when your liver starts to die if you drink too much, but we now know it affects lung health, and I am particularly, of course, interested in the brain. And while lots of folks have been focusing on these neuroinflammatory pathways and all of this, my favorite friend in the brain is a neurotransmitter called glutamate, as Nicole mentioned. Now, glutamate is the most excitatory, it's the excitatory neurotransmitter in the brain. It's absolutely crucial for learning and memory and thinking and reward pathways, and alcohol blocks it. That is the key take-home message number 1. When you drink, you shut off your glutamate. And just like a little bratty kid, if you tell that kid, no, don't do this. If you tell that kid to stop a behavior, the second you turn your back, the kid's going to act out, right? And do the behavior even 10 times worse than they were before. That's what happens to the glutamate system. So when you're using alcohol chronically, what you see is this big upregulation, both in the amount of glutamate release, as well as all the different kinds of receptors that take that glutamate signal. And if you don't believe me, here is a beautiful pyramidal neuron. It's called pyramidal because it looks like a little triangle, looks like a pyramid. And it's just growing in a dish, just hanging out. And then we apply alcohol to different concentrations. We'll just focus on this one here. And the little white dots, those are a kind of glutamate receptor called NMDA, super critical for learning and memory. And what you see is the neuron has these receptors. That's how we learn and we remember. But after alcohol, we have a huge upregulation. You now see so many more, and it's quantified down here, more than double the number of these receptors. And while you think, hey, that's going to be better learning and memory, sadly, no. It creates a lot of noise. Cognitively, you can't pay attention properly, but more seriously, when you upregulate these receptors, do not worry about all the stuff in between. Just focus on this word right here, these words. When you activate these receptors, they can lead to cell death. So, by chronically drinking alcohol, you are then increasing these receptors, as shown here, and that then increases the cell death. So we think this is what's going on in individuals with heavy alcohol consumption. So the big question I had was, well, does this just happen with binge drinking? Chronic, huge amounts of alcohol. What about, a couple of hours a day? What happens there? And so those were some of the first experiments I did when I came to UCSB. So what I did was I had mice binge drink one time. That's the SHAC1 group. Or I had them binge drink 6 times, twice a week for 3 weeks. And I put a probe into their head and I looked at neurochemicals. And as you see here, first day of drinking, no big change in that excitatory glutamate. But after 6 bouts of drinking, boom, suddenly huge glutamate release is happening in these animals. On the opposite side, our big inhibitory neurotransmitter, GABA, goes below normal. So we end up with this big imbalance of more excitation, which we know can kill your brain, and less inhibition. We then looked for the receptors. Do the receptors also change? And so don't worry about all this, but basically the guys who have the binge drinking, they're the black bars. And we see for quite a few different glutamate-related receptors, indeed, we're seeing both that increase in glutamate release from binge drinking as well as some of these changes here. So we are getting an augmentation of excitation of the brain, which can be neurotoxic. So then what about older age? We know that with older age, that things start to go bad. Those start having natural age-related cell death in the brain. Will the alcohol during our aging process speed that up? So the first thing we had to figure out is we know that this old mouse is going to drink. This old mouse ain't allowed to drink no more. It also smokes cigarettes. So Mickey used to drink back in the day, but we don't know because there hasn't been any studies studying whether or not old mice would actually binge drink. So our first job was to figure out whether or not that was the case. And what we do is we seek out animals. We have this cool little chart that we can go to. So if we want to look at drinking over the age of 50, we want to look at the age, drinking around the age of 80, we can order in mice that correspond to those age groups. It's not perfect, but what we did in our experiments was grab some mature adult mice. And so they're actually 6 to 9 months. So they're sort of at the 35 age group. And we compared them to some middle-aged mice who were 18, well, I guess we're over here, older mice that were 18 months of age. And I got to speed this up. So we basically did a happy hour experiment. So the animals are in their home cage, and unlike Azul, where you get lovely cocktails with delicious flavors, we just give them grain alcohol. These mice, these C57BL6J mice, they have something up with their taste buds. So you can give them grain alcohol and they'll drink it fine. You don't need to sweeten it or flavor it or anything. So we gave them a little choice, open bar 10%, 20%, 40. You want a strong beer? You want a wine? You want hard liquor? We got your choice there. You drink whatever the heck you want. You got 2 hours. And we did that for a month. So this is like, taking a month vacation somewhere. And what we found is kind of, like what I see with myself. So we drink a lot and then we back it off, and we drink a bit and then we back it off. So we see that pattern in the mature adult mice, and we see something very similar also in the older mice, the 18-month-old mice. The thing I would like to point out, I'm sorry that this data point's really low. Samples got left out of the freezer, so that's the problem. But what I want to point out is, even though overall, you can see here that the older mice drank less alcohol, look where their blood alcohol levels are, all right? Because your metabolism's slowing. So they're drinking less, but they're still not able to drive. So this actually was beautiful because it matched what we see in humans. So we know they're technically very close to binge drinking, and they're doing it pretty much over the month. So here's the big thing. So we did a Morris water maze experiment, and we did a couple of different stages. And the first one is, hey, can they find a platform that has a big flag on it? Like, can they see? Can they swim? They're older. We don't know. We've never studied. We study teenager mice most of the time. And what we found, so let me orient you, the younger mature adult, so me, my age, mature adult mice are here. The older mice, 18-month-olds, are on this side. What you see is very clearly drinking is the yellow. The drinking increased the time for them to find the flag. Their swimming speed was fine. They can find other things with their eyes. So it wasn't that the alcohol made them blind or made it harder for them to swim. They're in alcohol-free state now. They're in withdrawal. And the booze history is making all of them worse. Then we go on, okay, they can swim, they can find a platform. Let's go hide that platform, and they have to go find it. And when we do that, what you see is only the female drinkers. So guys in the audience, you're good. Of both ages, only the females took a heck of a lot longer to figure out where this platform was hidden. So we start to see some female selectivity here. Then we take the platform out and we say, hey, you learned the platform was there. Prove it to us. Show us your memory. Go swim around where the platform should be. And what we see again, doesn't matter the age, doesn't matter the sex, that drinking history is making it worse for them or impairing their memory on this test. So they're taking longer to tell us they remember where things are. And then this one, we decide then, all right, we're going to move it to a new place. Can you learn to reverse your thinking? Can you find it in a new place? And here's where we got a really interesting interaction. The females of both ages were not very good. Males were actually improved. So taking all this together, definitely whether you binge drink for a month as a mature adult or you binge drink as an older adult, you are showing memory problems in this particular task. So then we moved on to a much more complicated task. I'm running out of time, where they have to find 4 different hidden platforms. Well, make a long story short, what we see is mostly effects in the mice my age. Females in particular take longer to figure out this maze. Males and females make more errors in this maze. And the younger females do something weird. Instead of saying, I remember the platform's here and then it's here, instead they just go in the pool and they swim. Armed, 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 armed. They've been in there for freaking 10 days. They should be learning this. And they switch and just go do, 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 which is what we see in mice that have schizophrenia-like symptoms. So they're not using their hippocampus. They're not using parts of their brain for memory. They have to switch strategies. And it's the younger females that are showing this. So then we went and looked into the brain. And here's where the ladies are going to be happy in the room. Age-related drops in our glutamate receptors are only happening in the male mice. Alcohol changes in glutamate receptors are only happening in the male mice. And this is all in the hippocampus, which is a key part of our brain involved in learning and memory. When we looked at some markers of Alzheimer's disease, and what I want to make very clear, this strain of mouse does not develop Alzheimer's. They don't develop plaques and tangles or any of these characteristic features that we see in other genetic models of Alzheimer's, but they do show changes in the way some of these Alzheimer's proteins are looking. And it's a complicated thing, but I'll let this just speak for itself here, that sometimes we saw things change in females, sometimes we saw them change in males, but quite often we would see, like in the case over here, that both males and females would show some markers of neuropathology. We then move to the prefrontal cortex, and we have a very different story. The prefrontal cortex, the part of your brain that develops the latest, still developing until you're 35 years of age. It's one of the reasons why the drinking age is 21 in this country, because it used to be believed that 21 is when this part of your brain is finally mature. It's your decision-making center. So of course, we want people to be able to make good decisions when it comes to purchasing cigarettes and alcohol, etc. It is exploding with alcohol-induced changes in glutamate receptors. Males, females, younger mice, older mice, and we have never seen this in younger animals. Prefrontal cortex is pretty okay, doesn't show a lot of alcohol changes. So this was our first time seeing these huge changes, but it's happening in older animals, which bringing up all sorts of questions that we still have to answer. So that's blowing up. And then when we look at some of our Alzheimer's markers, again, some changes are only in females, but these ones particularly related to the tau protein that can make tangles, we see that there's really no sex difference. And I'm wrapping this up, Nicole. So hopefully I have convinced you that older mice, even if they're 1920 there, can binge drink. They will binge drink, and they'll do so over an entire month. That's pretty awesome. And it appears from the work that we've done so far that females might be more sensitive to some of those cognitive impairing effects. Certainly the males were showing some issues too. But if you count up the number of problems, the females were exhibiting more cognitive problems than the males were. However, when you go into the brain, even though the males showed only a fraction of the cognitive impairment the females did, their brains seemed to be more affected, both with respect to age, particularly the hippocampus, with respect to age and with respect to alcohol. So one idea we have is that the brain is changing because of that alcohol experience, but males are just slower to show the behavior. So you got to have maybe more change. You might have to have more robust change in the brain before you see the behavioral consequence. Whereas with females, you start messing up your prefrontal cortex and you're already going to start seeing some cognitive abnormalities. And of course, we go into the Alzheimer's markers. We're still early in this study, but there definitely looks to be, again, some sex differences there. And the big question is, how do those relate then to why the females are showing more behavior and the behavioral problems than the males? And we still have a lot of work to do. So one big aim that we're trying to do, because we are part of CALS, is to try to understand why females might have some changes in certain proteins and males not, and why females are showing abnormal behavior before the males do. And one really cool enzyme, unfortunately, the drug is crazy expensive to target it, is this guy called GS3K beta. We know it's responsible for phosphorylating tau, and that we see is changed in our mice. So we'd like to see if we could block all this from happening. Can we prevent alcohol's effects on behavior? And as I alluded to earlier in the talk, a big one, again, stemming out of the COVID-19 pandemic, is isolation, social isolation. We know in particular that The older you are, well, if you're a teenager, that's another story. Teenagers massively impacted by social isolation, but so are seniors. And there's been a whole lot of work focusing on adolescents and the permanency of that social isolation. How has it changed their brains? Has it changed it forever? But there's been, again, a lot less work on older individuals. So we're really interested in how social isolation changes the brain, which might make you drink more and might lead to cognitive impairment. So that's a big ongoing project. So with that, I'm not saying don't drink. Just drink. Speaking of which, where's my beer? Just went the whole talk, I didn't even have a sip. So we can drink, just drink wise. So that will hopefully help us age well. And with that, I'd like to thank the gang. So all of my super beautiful students, they all graduated last year. Leo is now at Yale. He was my graduate student. He's postdocing in a human animal lab looking at alcohol use disorder. Sam Scudder is, why is this cursor thing not moving now? Sam down below here is currently a teaching professor in psychology. She was my postdoc there for a while, who right after COVID helped me get a lot of this stuff undergoing. And with that, I am totally over time, but I will take questions. Thank you. So there is actually a glutamate supplement. I wouldn't call it a supplement. It is a vitamin called N-acetylcysteine. You can buy it at GNC. That is capable of restoring glutamate when glutamate is too low. The problem in an alcohol brain is glutamate is too high. So that supplement probably wouldn't work. So to try to think of, and this has been studied in the alcohol field, different ways of quieting down the glutamate system have been tried, not clinically, only in animal models. There's one drug that has been approved for treating alcohol use disorder. It's called acamprosate, and let me go back up here. It gets one of these glutamate receptors. Okay, my laser pointer is totally gone now. It gets here, I'll just walk it. In one of the blue or green guys, it'll block that. And that drug looks like it works for craving alcohol. Problem is, you need that receptor to think normally. So when you block it, and this is the problem with targeting glutamate, we can't block glutamate. We block glutamate in the prefrontal cortex, we'll develop symptoms of schizophrenia. We block glutamate in the hippocampus, we develop amnesia. So the trick has been trying to figure out a way to tone the glutamate down without blocking it completely. And that has proven to be a really big challenge. So currently we don't have drugs that I'm aware of that are just able to take it down to get you to a happy, normal medium. So we do treat people with GABA drugs that stimulate the GABA system if they show up in the emergency room. So when they're in alcohol withdrawal, people tend to have convulsions, so it's all about the excitation of the brain. But in terms of treating someone with alcohol use disorder with GABA drugs, you tend to, if it's done, they'll be given benzodiazepine, so like Valium, to treat any hyperanxiety. It's all about the emotion and trying to keep the person less anxious, then they won't go and relapse. GABA, you don't see folks targeting the GABA system for memory, but there's no reason to think that by helping GABA out, and taking the glutamate down, you wouldn't help memory. I just haven't seen it done in that context. But for sure, if someone shows up in the hospital with full-blown alcohol withdrawal, we want to shut off that excitation because it can cause strokes and brain damage. So we will give them GABA drugs. So you're thinking along the right line. It's just never been applied to the best of my knowledge for the memory aspect of things and the cognitive impairment. Well, what you're going to do by taking those at night is you will help prevent that glutamate upregulation that is happening should you be drinking that night. But right, like people do take GABA drugs for sleep aids, and they take GABA drugs to treat anxiety. But in terms, and that's going to stop the neurotoxicity, but whether or not it might improve memory, I don't think people have looked at that yet.
Well, I read something, the research focused on drinking what would this only can apply if you have to say one drink a day? There's 7 drinks to spread out as you
So in my shack model where I showed you the glutamate change and the protein changes, that's half an hour of drinking a day. So it's actually a very short period in that model. It's a very complicated model that's hard to run because you have to like change their light cycle and all of this. So now we've switched to just 2 hours a day because that's your standard binge drinking. But no, we know all the effects of alcohol are dose and experience dependent. So that's where I was saying drink wisely, live well. Because drinking itself, having a drink or two, is not going to be inducing these sorts of changes. But if you start to engage in patterns of behavior like the happy hour multiple times a week, or the drink and watching basketball and hockey going on, or baseball going on right now at home multiple times a week, you are going over that threshold and potentially inducing these sorts of changes. But 1 drink, 2 drinks, once a week, once a month, is not going to induce these sorts of, we know this from human studies. You also don't see the cognitive decline that you see. 1 drink every day. The human literature would say that that's less of an issue. So that was in that crazy slide with all the blue lines going up. So where did it go? So if you were, oops, why is it? Oh, it's not. Hold on, I got to go to slideshow. Is that going to do it? Nope. It was based on the number of drinking units. There's no cognitive, sorry, I've got the graph in front of me, but you guys can't see it. Low alcohol units, no change. It's about having too much is when you start to see the problem. But are there animal experiments where they only look at 1 drink a day? You know, so what would that be in a mouse, right? Is that like 2 minutes of alcohol access versus 2 hours? We can't really model that easily in animals, but from the human work, it would suggest it's a cumulative thing. So 1 drink a day. The director of the National Institutes on Alcohol and Alcohol Abuse has changed his tune and says no alcohol anymore. That's his new stance. But the data, at least that we have right now, would suggest I'm not going to say 1 drink a day is okay because I'm not a physician, but the data would say, at least in terms of cognition, it should be okay.
Yeah. So I'm wondering, this is personal. From
I didn't share any stories at all with you.
20 to 40, I was the binge drinker, like what you've described. And then all of a sudden I realized all the alcoholics in my family and totally stopped drinking. So my good friend over here, Regina, just threw a book at me on neuroplasticity. So I'm wondering, since we know the brain can change and do things, I'm now almost 78, so I haven't been drinking.
Looking good.
Long time. Can I assume that my brain has made positive changes and that I probably don't have sustained damage from those years of binge drinking?
This is one of the hardest questions to answer with scientific data, because what experiment has been run with humans across their entire lifespan to see? What I can say is data from younger folks over, across drugs of abuse. So if you're a heavy user in high school and college, maybe up until 35 or so, and you stop, you have a time-dependent improvement, at least in how your brain is connected, doing imaging studies. So I would argue that yes, there's a good chance that because you have started to make healthier decisions in terms of your drinking, that's likely spared you from the trajectory that I am still on. I'm not joking. It's like every day this week, I have been out drinking. This was my birthday week, but that's it. It's my birthday week, right? Like I can justify it, but I'm 53 years old now. And according to my data, this is me. This is me. This is me. Everything's up, right? So the drinking that I'm doing now, unless I don't start changing my behavior, I don't think my faculty reviews or the faculty reviews of my teaching ability is going to start to go like that, because you're always wondering, like, am I having a harder time remembering things because I have 2 teenage daughters, I'm teaching these classes, I'm doing this, I got brainiacs, or is it all together, right? And that's why studying humans is so difficult, because you can't parse those things out, but you want the human answer. So this is in large part while we're trying hard to do this. And in the past 5 or so years, there's been a big increase in the number of papers, because I get to review them, number of papers coming out looking at drinking in later life, like beyond the young adult mouse or the young adult rat. We're now looking at middle age and later age. So we might have some more good, but at least from the younger brain side of things, the longer you stay off, or when you start to moderate your use, that things do get better. Because this, you just imagine, it's cumulative, right? So if you're turning on that glutamate all the time, every day, that over your life, that's what's causing the brain damage, right? So if we can realize, maybe I'll chill it out and not go up to wine country this weekend and stuff like that, we won't have as big an impact on our brain. Yeah.
So, in 1978, I started practicing nutritional therapy with a company called Bronson. They were known as Bronson Pharmaceutical, then now they're known as Bronson Lab. And they were the first company to market supplements, since we had 3 supplement questions I thought I would use. To doctors. Because, doctors historically, no, you don't need to take vitamins, you just need a balanced diet. And that's what they say to everybody, right? As if the soil has not been touched in strawberries, for example. More strawberries, more vitamin C than an orange, pound for pound. But they paid it, and even Brian talk about oranges, and that's how the oranges got to be so common. But they're very acidic. Strawberries are acidic as well. Bronson had 2 doctors working with them, formulating all the products for the doctors. One, everyone in this room has heard of, they're over 50, Linus Pauling, right? Everyone knows Linus Pauling. He wrote the vitamin in his called book. And he's the only doctor, you know, that has ever won 2 Nobel Prizes. The other doctor, no one's ever heard of, Dr. Roger J. Williams, University of Texas. He discovered pantothenic acid and vitamin K. He also wrote a book called Biochemical Individuality, and he proved that everybody is different. He had 250-pound women, you know, but one of them's 5'10", I think. Yeah, different. So he said, now I'm going to do a book on alcohol. And so I'm treating someone in my state college class, not my class, Dr. Spencer Sherman's class, and got some alcohol issues. And so I know that one of the 2 books at the library, Santa Barbara, I don't know who yet, but he wrote 2 books specifically on alcoholism and nutrition. And he proved in the lab with real people, you take this vitamin, and you can actually, you don't have to go to a 12-step program, you don't have to believe in God, you know, it will take away the craving for the alcohol and many other, you know, drugs or anything that is considered addictive. Some people it's sugar. Most people don't know that sugar gets converted into fat in your pancreas. You know, so they're eating fat-free foods.
Right.
They should be eating sugar-free foods. So anyway, just Roger J. Williams mentioned alcoholism. You'll find one of those 2 books. They're very, very thin paperbacks. You can read them in a couple hours. This is not an encyclopedia.
Well, thank you for that.
Oh,
So I had kids. And then I was at the daycare center at Orphalea here, and they were asking parents, well, can you do some extracurricular? And I said, I guess I could bring in some brains. And then we did some fun experiments, where they plug their nose and close their eyes. I give them a piece of grapefruit. So they don't know what it is, but they're like feeling it and they have to guess. And then you let them smell and taste and they figure it all about their 5 senses. And we do funny little things about, remember when grandma or grandpa or auntie made cookies, and then you see all the kids smiling and you're like, wait, why are you smiling? How does that memory give you emotion? You know, so we did all that goofy stuff. And then they went to elementary school. So that's when I found out about the science nights that a lot of the schools have. And oh, by the way, if you are affiliated with any elementary school that doesn't have a science night, like some schools don't, they don't have parents or teachers who are willing to organize them, we're more than happy to come in and we can just sit in the gym or sit in the multipurpose room, and the science classes can come and visit us instead of going to science class. So please let me know if there's a school, because there's a lot of schools we're not hitting. We do 12 or so, but there's still about 6 or 7 schools. But that's how it started. And now my students are so into it that I don't even have to be there. They're running the show. We do pipe cleaner neurons. We face paint neurons on the kids' faces, and they get to put on gloves and pick up cow brains and sheep brains. We have spinal cords. And yeah, and they love it. So it stinks, right? They're like, stinky brains, but and you see the best is you see the same kids from kindergarten through to 6th grade, you know, and they're like, oh, the brains, what are the brains? So yeah, we're very popular in town. Joel.
So I think to end these things with my own question, I always slip in. So when I was a winemaker in my other life, professional winemaker in California, it was a time when, in fact, there was almost a recommendation to be a moderate drinker. There was a claim that we were healthier as moderate drinkers than non-drinkers. And now, as you said, the director of the
NIAAA
has recommended 0, which is really kind of difficult for a former winemaker and wine lover to accept. But
he also gives me grant money, so that makes it really difficult too. Yeah.
And you're right. The one you mentioned, the blue line. I don't know if you can pull it up, but it showed that there was actually an improvement at a few drinks. So that
I'm looking at it right here. Yeah, there's a little bit of improvement though. So little.
Well,
so
was it not significant?
No, because of the degree of error there. No, so the news story, I mean, we've all gone through this, right? Ketchup, great for you. Ketchup, tomatoes, great for you. No, they're not. Alcohol, a couple of glasses, okay. No, they're, and, you know, they were trying to decipher what is the ingredient in the red wine, this red wine in particular. Yeah. And, so now the news story is when you were drinking that red wine, you were also partaking of a more Mediterranean diet, typically. I don't know. They've never been here because we're eating freaking tri-tip and mashed potatoes and having a glass of red wine. That ain't no Mediterranean dinner. But so now what the news story is that a lot of the improvement in health and well-being was because people often were drinking the wine with that Mediterranean diet.
And perhaps in a more social setting, maybe.
Yeah, there's so many, that's again why I'm like interested in the social isolation, changing in the brain and how that's interacting with alcohol, because definitely having that social setting is huge. We know.
I'm mostly curious because I think you saw that multiple times. It wasn't just one time. You still say it wasn't, that drop was still not.
Yeah, on that blue graph. But I mean, the thing that really strikes me in good news for a lot of folks in this room is the older mice. This is so weird because I keep thinking it's an actual, no, I feel like it's supposed to be a hanging down screen. And it's like, what? There's no change in the older animals. It's only happening in the younger animals. You see it in males and you see it in females. So I am fascinated by why, going back to that plasticity question, is this because there's less plasticity in the brain? So we can't usurp it and drive it like we do in a younger brain? And there's all sorts of questions. I want to do electrical recordings and all that to see what might be happening with plasticity in these different brain areas. So at least from my data, there were some cognitive impairments in the older mice, but they don't seem to be overtly related to these markers of Alzheimer's or changes in glutamate. So what's driving them is a whole unanswered question. But I'm still going with, you know, if you like tomatoes, eat them. If you like a glass of red wine a day, drink it. Because, you know, there's also part of it is you got to live your life, right? So just drink well.
I would remind everyone, as I said in my lecture, that Jean Cambon, who lived to 122, had a glass of red wine with the Gabriel.
Look at grandma playing beer pong, man, 100 years old. And Grandpa Kippen, my husband's grandpa, lived to 100 and almost one. He had a Clamato and beer. It's a British thing. A Clamato and beer every day, like his religious little, that was his thing. He'd sit on the news and have his beer every day. So who the heck knows?
Thank you so much.